Welcome back, everyone. Today we'll be covering the immune system. The immune system may seem complex, but it's not. It's really not. It's fairly simple. In the immune system, there's four cells that you need to worry about. These four cells are the white blood cell, the B cell, the T cell, and the macrophage. I always think that each of these cells is very kind of similar to some type of civil servant. So the white blood cell is like the police. They track down and seek out the bacteria, or maybe they might find a stray virus in the body. So they come over to it and they eat it like Pac-Man. The term is phagocytosis, and that just means cell eating. So to do that, the white blood cell comes and it's gonna like extend the part of it around the bacteria until it's fully around it, and it just closes off and it just dissolves it. It just eats away at it. The T cell is almost like the SWAT team. A T cell will come to an infected cell. So this cell, if you look closely in the nucleus, it has both green and blue segments of DNA. So the green is a DNA that should be there. That's like your DNA. But the blue in there, that's viral DNA. And when the cell realizes that it's been infected by a virus, it'll send out the signal to call for help because it knows that it's bad and it shouldn't be doing this. So the T cell comes over. It'll use these chemicals to make the cell pop, just to kill the cell, because if it's replicating viral DNA, it's no good. The macrophage I think, is similar to the garbage collectors, the sanitation workers. So a macrophage will come by, it'll pick up some like dead things. So there might be a dead bacteria, or there might be some dead. There might be this dead cell. The macrophage will come over, and it'll eat it up, and then it'll bring around and get rid of it because you don't need anything dead in your body. So these are like dashed lines. So the macrophage, similar to a white blood cell, will like stretch part of itself around the garbage, and it'll eat it and bring it inside, and then it'll carry it away. The B cell is really cool because around the B cell are all these things called antibodies. Antibodies are just the little like caps. So before I expound on that idea, I need to say that all cells of any kind have these things called antigens. Antigens are like flags that mark out like who is who and what is what. So all of your cells that make up you have antigens that say, I am a good cell, I am a you cell, please leave me alone, I am nice. But bacteria also have these antigens, and that may allow them to bind to our cells and get inside and infect us. So what the B cell does is it can take the antigens from things like bacteria, or if one of our cells has been infected and it's presenting the bacterial or maybe viral spike proteins, which are also a type of antigen. So the B cell will take any non-U antigen, it'll bring it inside, it'll analyze it. It's almost like James Bond always has his cool tools that he gets. The B cell is like the person who's making those cool tools. The B cell will bring in the antigen and read it and figure out what it is. It'll spit out all these antibodies. And antibodies are specific to the antigen. It's very similar to what happens with DNA. Like A and T and C and G always pair together. So antigens are specific to what antibody they need. So this green square antibody will bind to a square antigen. Similarly, these blue like Y shapes will bind to triangular antigens, and then these red semicircles can bind to circular antigens, and that way those antigens can't go anywhere else, can go anywhere else, do anything else. They can't bind to our cells and make us sick. So the B cell can also remember every single antigen it's encountered. So it could have this big book of all the diseases that your body has fought off so far and recovered from and made antibodies for. Because it wouldn't make sense if you had all of the antibodies in your blood at all times. Instead, what happens is if your body encounters a certain bacteria or certain type of antigen that it's already encountered, already knows how to make antibodies for, it'll start mass producing those antibodies. Hence, if you get infected by a certain bacteria or virus or whatever, a second time or a third time, or like anything beyond one time, your immune response is almost immediate and is really strong. That's why vaccines work. Vaccines work by presenting antigens or germ DNA, so that the B cells can see that and say, okay, this is bad, I know what this is, and so in the future, if you ever encounter that as like an actual fully fledged germ, your B cell can say, okay, I got this. This is this, and we're going. It's making all the antibodies it needs in order to put like little bottle caps on the antigens. So those like bad antigens can't bind to our cells and make us sick. Another cell which I didn't draw on my board because it's not all too different from other cells in the immune system is the natural killer cell. So that cell is most similar to the T cell in that it's meant to deal with like our own cells, but the natural killer cell is interesting in that it tends to attack cells that would become cancer. Hence, it's called the natural killer cell. So natural as in like us, and like what should be there, and then killer. As per usual, if anyone would like a more in-depth explanation of the immune system, I will happily provide. And in the meantime, I hope you have a wonderful morning, afternoon, or good evening.